Rates of reaction are related to stoichiometry. And this is one of the very few sections where I disagree with how the textbook presents things. The textbook presents this concept very correctly, but I don't think it presents it in a way that is intuitive or that builds on things that you've already learned. So recognize that for this course, you can do things either the way I'm going to teach you now or the way the textbook presents it. Both are correct. So in this video, we'll be looking at an example of an acid reacting with a base. If you know the rate of reaction for one of the components in a reaction, you can find the reaction rates of the other reactants and products using stoichiometry. Remember that rates are presented in units of molar per second. And another way you can write that is moles per liter per second. And you can connect the moles of reactants and products using stoichiometry. So consider what happens if you have a rate of reaction of 0.5 molar per second for sulfuric acid. Presumably this concentration is decreasing at a rate of 0.5 molar per second because sulfuric acid is one of the reactants. We can use this value to determine how fast calcium hydroxide's concentration is decreasing using some mole ratios, exactly like we've learned how to do in the previous course. When we do this math, we find out that calcium hydroxide's concentration is decreasing at a rate of 0.5 molar per second, which is actually the same rate as the sulfuric acids. And that makes sense because the balanced equation and the stoichiometry tell you that you need one calcium hydroxide compound to react with every one sulfuric acid. So if your sulfuric acid is decreasing at a certain rate, and the stoichiometric coefficients are the same for both calcium hydroxide and sulfuric acid, the calcium hydroxide also needs to be decreasing at that same rate. And the same thing is going to be true for connecting reactants to products. So we can work out the rate of formation of water. And we find that water is being formed at a rate of 1 molar per second.